What's up, everybody? I'm Tucker, and this is Tuck Talking Tech, and today we are talking production AI. This is part one of a five-part series called Full Stack RAG, where we will be starting from architectural blueprint and system level requirements and going all the way down through code implementation, with the end result being a full stack chat application with a RAG capability as well as a GenAI chat interface. So first, let's start with why are we here? Why am I here? Why am I sitting in front of this camera preaching to you about production AI? So there are a lot of great resources out there about prompt engineering, agents, RAG, POCs for chat applications. Pick your favorite buzzword related to AI, and I'm sure there's a really great resource about how to do something with it in 10 minutes, which is really great and really powerful. But what I see is there's a general lack on how to take these things and get them into production. How do we build these things with next year's requirements in mind, and architectural and system level thinking from the beginning, and setting up code in a way that scales not just from a usage perspective, but from an extensibility perspective, and thinking about enabling capabilities at scale and behaviors at scale, and minimizing the amount of code and maximizing the efficiency. So what we're going to be going through is some of these design level concepts and framework ideas that I use to solve problems and that I find to be very powerful in the context of bringing AI into production, and how to go from POC level thinking into production level thinking. So just to make it really clear, this is not another prompt engineering guide. This is not about how to build the best agent in the world. This is about how to address modern technology problems with modern technology thinking. So with that in mind, let's talk about philosophy here and why we're going to be building the way we are. So as many of us are familiar with, there are many different AI coding agents out there that enable us to write code faster than ever before. Pick your Claude Code, pick your Codex, whatever it is, pick your favorite coding agent. Those things are there, and they're really awesome, and they're extremely powerful. And because of that, we're seeing that code is something that's beginning to be what I'll say commoditized, or it's something that is no longer the biggest constraint that determines the success of our system. Is the ability, or the speed in which we write code, because we have things that can literally type faster and can turn ideas to life, given that they're the right ideas, to life in a very short amount of time, and we're able to get things into users' hands. So I'm going to make a claim and that claim is that architectural thinking and system level thinking is now more important than ever, because that's where the bottleneck exists. It's taking business requirements and converting into something that AI can actually act on, that we actually want to write code against. And getting that right up front is also now more important than ever, because we really have an opportunity to set the course of our application or our systems very early on up front and get it right, and establish code with best practice in mind, with scalability in mind, so it's things that we are extending and that we're not refactoring. And as someone who is an engineering leader and an architect, this is something I see across the board that's the biggest challenge, is to think at this system level, to sit down with the business and define a technical specification that not only solutions for today, but solutions for the next 2 years, or at least keeps things open enough that when we need to extend or we need to pivot out of something a decision we've made, it's something that's relatively seamless, and we don't have to go back and say, hey business, I need a 6-month refactor because we didn't see this coming. This is the sort of thinking we want to do up front, that then bears itself in code and enables us to move a lot more efficiently, work with AI in hand to be able to write code faster, because we have a really clear understanding of our intentions of the system, the capabilities of the system, and how we want to actually structure our code to achieve those things, so that we're building things that are composable parts and not things just jammed into one messy script or some real bad Python that's doing a million things at once. Pick your worst code base. Those things tend to really bear themselves out in AI, because we're dealing with non-deterministic systems, and so we have to be even more careful about our separation of responsibility and being really clear in how we're defining that, so we can make things that are testable, composable, extensible. Pick all your favorite object-oriented buzzwords. Those are the things we're all going for here. And I'm going to argue throughout this whole video and make claims that this really matters. So before we go any deeper, I want to start with an analogy. And the purpose here is to really drive home separation of responsibility and why this matters in software and especially in Gen AI systems and Gen AI systems at scale and in production. So we're going to start with an analogy here, and that analogy is let's envision that we're creating a restaurant, and that restaurant is going to serve several different types of food and desserts. When we're looking at the requirements of our restaurant, we know that we're going to need to be able to take orders. We're going to need someone to actually cook the meals. We're going to need someone to clean. We're going to need someone to sit at our patrons at tables. So we have a lot going on here. Just there, I think that's 4 things, 4 different responsibilities and capabilities we've identified. So imagine in our kitchen, or in our restaurant, we are very disorganized. We allow anyone to pick up any of those tasks. So we have the chef who is also sitting people. We have the chef is also taking orders. We have the person taking orders, also cleaning dishes, and we're trying to accomplish all these things at one time. And there's no clear instructions. There's no clear ownership over who does what. So imagine your experience as a patron coming in and trying to get help and not knowing who do I go to, who's actually the person that I reach out to. I see Tucker is waiting tables and he's also cleaning dishes. Is he also going to be the one that's taking my order and sitting me? There's so many questions and so much disarray that arises from this scenario. And so then imagine that as you try to make that more efficient, where do you start? Where does the bottleneck lie? Is it in the person cooking the food, or is it because the dishes aren't being cleaned in time that everything is such a mess? It's very hard to pinpoint what is doing what. Why are we failing? So let's take that same analogy and translate that into an actual implementation, thinking about code. So just as our restaurant is in disarray, imagine we design a system where we have logic spread all across the application. We have prompts living in different layers. We have HTTP logic sitting down where we're querying the database. We have a prompt that is instructing many different things at once with multiple redundant instruction sets. So one, if we think about that from a developer experience perspective, where you're stepping into the system trying to understand, well, what's going on here? How do I extend this, or how do I contribute to this system now? It becomes very challenging because things are all spread out. Similarly, imagine something breaks. Imagine this is our RAG backend, and we have our prompt, and our prompt is doing many different things at once with many instruction sets. Well, how do you identify which part of the prompt is causing a failure? Similarly, imagine you have application logic spread across many different layers within your implementation. How do you know where the performance hit is? How can you isolate behaviors? It becomes near impossible if we don't set these things right up front. So these are concepts that have lived for a very long time in the context of just general software development that I'm going to continue to claim matter now in a Gen AI context more than ever, because we're dealing with non-determinism and we have more layers to test, and there's certain guarantees about our system that we want, that being latency, accuracy of responses, adherence to context, retrieval accuracy, all things that we want to be able to test in isolation so that we have a lot of confidence on the code we're writing and the capabilities we are exposing. And so with that in mind, let's make this real. So I've made a lot of claims, and I'd like to now take this into an actual application that I've chosen to stand up for the purpose of going through these concepts and exposing these in a way that's as concrete as possible. So with that in mind, let's step into the repo here. So here we are in the repo, and I will be posting the link to this in the description. There's a lot of architectural documentation, some of the motivations for why we're here, and explanations for things that I'm covering in the videos, but just if you want to go back and maybe skip through the videos and just see some of the content, how it came to life, you can certainly come check this out, and hopefully it's of use to you. So let me first highlight what was built and why this is a good use case for what we're doing. So the name of this is called YourFit.io, specifically YourFit. So I am a former professional baseball player with a love for baseball as well as technology. And so at one point in time, I had this idea that wouldn't it be cool if there was an application that helped high school baseball players decide where they should go play baseball in college. So this was a challenge that I faced growing up, and I thought it would be nice if I could use my skills to help bring this to life. And so ultimately along the way, I thought, well, there's some really cool stuff going on here for how I chose to solve it. And I thought, well, it'd be really nice if I could use this as a study for how to write one of these sort of applications at scale with the production mindset. And so that's why we're here in this repo, and this is YourFit. So YourFit provides a capability for you to choose a school that you're interested in, that you want to go play baseball at, and then actually have a chat with GenAI about is this a good fit for me? Should I actually go here? And so under the hood, there's a RAG capability that goes and retrieves some specific context about the coach and then gives you an answer based on your input that's customized for you, saying, okay, given these attributes that you're telling me and given this context, then this school maybe is or isn't a good fit. There were some steps I had to take beforehand to actually gather the data. There was some web scraping. I had to throw this in a database and do some basic analytics on it. That's out of scope for what we're going to be talking about, but just know that that was part of what into actually gathering this data and actually enabling it for our RAG framework. Could do some more I could do a lot of videos on that because that's really fun and really cool from just an analytics perspective and data modeling and structuring all those things. That's another topic in and of itself that's out of scope for a lot of reasons, and that there's only so many hours in the day. And right now we're focusing on this chat application and the capabilities that go with it. So we've explained the actual concrete use case, and that's a GenAI chat interface to be able to get recommendations on where you should go play collegiate baseball. So anyone, if you're trying to decide on your scholarship, I got your back. Got this app. Come use. Just kidding. But so let's first identify technology stack. So the front end is React with a Next.js backend. I have intentionally omitted the actual code piece of the React framework. We will be talking about some of the front end architecture and how that is actually driving some of the orchestration for the chat capabilities, but we won't be going into the actual code. This will be more focused on the architecture as a whole and then the actual backend implementation and the code structure in the backend, which hopefully be relevant for a lot of people here. And I'll just highlight two front-end capabilities and front-end code, extremely important, extremely powerful, and not something to be overlooked, but for the purpose of these next few episodes, we are going to leave that to the side. So our chosen technology stack for the backend is we have it's Fast API in the HTTP layer. Our database is Postgres. We have SQL Alchemy as an ORM. The LLM provider that's currently in use is Anthropic. We'll be going over why that choice is less consequential to the system and how we've made that composable. The validation is done via Pydantic, integrates out of the box with Fast API. Also, I love just having the typing and being able to enforce that throughout the implementation. Get some really nice guarantees from a developer experience, as well as just being able to ensure the data you're getting is what you're expecting and what you're coding against. We do have a cache implementation that is it's in memory. We'll talk about why that matters and for reasons why also that doesn't matter in the code, and why we've been very intentional about making sure that the actual underlying cache technology is less important to the implementation and making the implementation really naive to the actual cache technology. I'll highlight too, if you're looking at the code, it's the design that I've chosen is a domain-driven design, and I've identified a couple of different domains that we'll be talking through in more detail in the next episode, and hopefully I'll be able to highlight why I think that matters in this case and why it's going to set us up to do some really cool things and really cool things with the future in mind. There's also layered architecture here, so we're drawing very clear boundaries between the API layer, application orchestration, data access layer, database provider, why some of those things matter, and why some of the things we say they matter and maybe they end up being less consequential, but still we've gone through and the overhead of actually identifying these layers and implementing accordingly. We'll talk about protocols versus inheritance, when it makes sense to use either and when they can be more powerful than maybe the alternative. We will talk about RAG as a capability and not just a feature. So how we can start to think about not just RAG for the purpose of this specific application context of chatting about coaches, but how do we think about RAG as just a generic capability that we might want to enable across a platform or across an organization for something that's enterprise enabled. Dependency injection, Fast API offers some cool framework level things, but you can extend that past Fast API and just as a general coding practice for those who write in object-oriented languages, especially if you're using something like Java. That's something that you'll see very often, and so that there's certainly no novel thinking around dependency injection, even a lot of the object-oriented principles you'll see, but we'll just make them make sense for this chat application and why some of this, it's the object-oriented thinking and the design level thinking that is really going to set ourselves up for success and be able to write some code that is really extensible and really composable, which really matters. We'll also go briefly into things like repository pattern, DTOs versus ORM. These are, again, just some software level things that are important in the design. And hopefully what I'll start to highlight and you'll start to see is that in order to bring this full stack RAG application to life, it takes a lot more than just writing good prompts and a lot more than just, did I pick the right embedding model or am I doing RAG correctly? RAG is super important. Prompting is extremely important, but so are all these other more software specific principles that are all required to bring something to life, and not just to bring it to life, but bring it to light and actually scale it and cover the needs of the system and cover the needs of the business. And so what's intentionally out of scope here is authentication and authorization. AuthX is a really cool, really powerful topic. It's been intentionally left out. As an extension of that, we also won't be doing any sort of user management. We don't have an identity provider. The consequence of that at an implementation level is that there are limits to how long your chat would persist. So since we're not actually managing users, that means we can't really manage chats over a certain lifespan from being able to actually step back into the chat interface and resume a conversation. That'll be out of scope because we're not actually managing users beyond just the session. Similarly, so as I said, front end, we won't be going into the code. We won't be talking about rate limiting or billing. That really matters if you were going to take this to, if you were going to deploy this for your enterprise, you would need to consider, okay, am I, given the model provider, if you're using a cloud provider, what are my concurrency limits? Well, how much does it cost? If you're using open source and you want to host things yourself, what type of throughput are you getting? Again, these are things that you would all enable via your strategic design level thinking to understand, okay, how many users do I have? What's my budget? What are my throughput requirements? These are all things we would assign up front as part of our system, and then we make sure that we right-size the technology choices accordingly. What's in scope for this is we want to enable chat persistence and retrieval. So we want to be able to store chat history. You could think about that if you're in the actual application, you want to be able to manage the history as it flows and be able to audit, and maybe at some future time to say, okay, this chat, here's all of the interactions that happened, and that could be something that's great for as you are analyzing your RAG capability or your agent and saying, okay, this is how well the chat's performing or this is where it's tripping up. You want to be able to store that chat. If we were doing authorization and identity management, authentication and authorization, as well as user management, then we would also need to be able to retrieve that history. So you can think of like ChatGPT, when you go back in and you want to resume a conversation, it maintains all of that, your chat, so that you can go resume that at any moment. So that implies there's some user management going on and able to enable that. Since we're not doing that, you won't see that in the UI, but we want to at least set ourselves up to do that. So then what's also in scope is talking about RAG as a capability, and then talking about our domain modeling and how we've landed on these different domains and why that matters both architecturally and then also just at an implementation level. So before we close out this episode, just want to do a little demo of how this actually came to life. And so here's our chat UI. And so we have, for those who aren't familiar with the NCAA, it's spread into divisions, and the NCAA is the governing body of college athletics. And so if you want to chat about a school, you first need to know what division, and that just helps subset them. So that's more of an application convenience. So you would go and say, okay, Division I, which is the highest, tends to have the schools with the biggest budgets, the larger schools, and most popular schools if you're not U.S. based. And then you would choose a school and say, okay, I want to go to Arizona State. And then you could type something about yourself and say, okay, I am a I'm a 6'4", left-handed pitcher, and I throw the fastball velocity is 92 miles an hour. Is this a good fit for me? So now our agent's thinking, and I'm excited because recruiting season's coming up and I got to make sure I choose the right school. Hope this is a good fit. Thinking, cool, great. The response is ugly. I'm getting marked down. We could do some cool markdown rendering in line here. Not doing that. Again, it's not the intention of this. But you'll see we got an answer. So it says, based on the profile about Arizona State, yes, this could be a good fit for me. Great, here's why. Pitching metrics, my velocity fits well within ASU's range with the team average is 91. The highest is 96, so I'm above their average. Great, could be a good fit. My height, I'm above average for a pitcher. And left-handed, they're in demand at the D1 level. And the program strengths, okay, they rank nationally. Number 1 in the Big 12 for fastball velocity, great. And then to strengthen your recruitment, so what's my grad year? Okay, my secondary pitches, academic stats, where am I located? So this context, or these answers, all driven from some pre-computed context. As I mentioned, those analytics that I scraped and came up with is all being fed to the LLM based on the question and the context that's being set from the application. So as we get into the code, we'll see how we bring all these things to life, how we model each of these capabilities separately, and then make something that's really cool and really extensible, and ideally something that scales really well. So join us for episode 2. See ya.